Welcome to another tutorial using ANSYS Workbench 18.1. In this tutorial we are going to look at a two-dimensional truss made of 5 members. Here are the 5 links or beams in our truss. They're made out of aluminum and steel, and they have different cross sections. Here's a square solid, here is a circular member, and we are going to focus on learning how to use different materials, different cross sections, and couple beams together that are not in the same direction. The truss is loaded with a -1000 in the Y and a 200-pound load in the X, given a horizontal X coordinate and a vertical Y coordinate as shown. The lengths of the links are shown here in meters. We'll have our origin at 0, 0. This member is 3 meters long in the vertical direction. This point out here is 4, 3, and 3, 1. We'll now go ahead and start ANSYS Workbench and generate and solve this model. So after opening Workbench, you come to Static Structural, click on it with the left mouse button, drag it and drop it. You can also simply just double click on Static Structural. This icon comes up and we can change the title of this. I will type in 2B Truss for title name, and we're ready to start dropping down through this menu and building our model. The first thing I'll do is add aluminum, so I'll double click on Engineering Data. This comes up and shows me that right now structural steel has been added to my model. If I want to add another material, what I do is come up to Engineering Data Sources and click on it. Come down to General Materials and click on it. And then I can scroll down here to Aluminum Alloys and click on the plus button. And when I click on the plus, aluminum alloy has now been added to my model. If I want to change any of those values in my aluminum, I can come down here and edit those values. I can now close these windows by clicking up here on the X, and my material now has a check mark like it did before, but I have added aluminum. And I'm ready to go and start to build my geometry. So double clicking on geometry, down here it says starting space claim and the red dot is going. This can take a while to come up, but you know that it's working by this red dot down here in the corner of the screen. I like to keep this window up because I can quickly go to any tutorials. I can also go to a help and a user's guide that is very helpful. So I continue to leave this checked as show at startup, and then I just simply close it if I don't need to turn to it. So here's space claim. The first thing I want to do is come to File, Space Claim Options, and I like to change the units to meters. So I'll click on units, come over to the length, click the drop down and pick meters. I'll then come down here and on the minor grid spacing I'll put in a centimeter, so 0.1 meters, and then 10 grid lines per major, and click OK. I'm now ready to go ahead and start to look at developing my truss. I can click here on the y-axis, and now I'm looking straight down onto my grid plane, and I can come up and start to build my model by clicking on the line command. I will go to the origin and click. And then with these dimensions, my first dimension was up 3, so I can simply type in 3, enter, and it will make my line. Now I can move this direction and I go out 4 there, so I can go out there on my grid and click on the 4. Now my next point down here is a 3 and a 1, and this is giving me an angle and a length, which can sometimes be more difficult. So I want to come over here and scroll down and pick on Cartesian dimensions. And now I can come over here and type in the values that I needed to get to my next point. This point down here is at 3, 1. This point up here is at 4, 3. So I'll actually type in 2 for the point that is highlighted now, and I will then click Tab and go with the -1. So now I'm ready to enter in my next members. I'll click OK here. I can come down here and I know that it just closes, so I'll click there. Now I'm going to hit Escape twice, come back up to my line, click on my line, come to this point, click, and then left click again, and I close out my design. Now I'll hit Escape again twice. I can come over and click on Pan, move my model to the center, and blow it up, and I have now created the geometry of my truss. Now what I need to do is go and add the different cross sections. This is done by coming to Prepare along the top menu and clicking on Profiles. The first profile that I'll create is a 0.1 meter square solid. So I'll come down and select the square solid, and then I need to come and hit Create. The next one that I will create is a circular solid. So I'll come to the drop down and pick a circular solid and hit Create. Now I have circular solids of different cross sections, so I will go ahead and insert a different or another circular solid and click Create. I have a hollow square, so I'll click my drop down and click on a solid or a tube, rectangular tube, hit Create, and that should do all the geometries that I have. I think I have one more solid circle. With those 4, I think actually I'll be okay. If not, I can always come back and add one. So now that I have those added, I can come over here and look at them in the drop down, and if I right click on rectangle, I can click Edit Beam Profile, and this is where I can come in and change the geometry of this cross section. I want to change the base, so I'll left click on base, left click on the current number, and I want this cross section to be 0.1 meters, and the height will also be 0.1. So I have now created that cross section. I'm ready to back out of this and go back to Design down here by clicking this button and click Design, and I can go back to my structure tree, click down here, and I'm ready to define my first circular solid. So I will right click on Circle, Edit Beam Profile, and now on my radius here I have 0.05 meters. So 0.05, enter, and I have now changed that cross section. Come back to Design, click Structure, drop my structure tree, look at my second circle, and my second circle has a cross section of 0.1 meters, so I will right click on Circle 2, Edit Beam Profile, and click on the radius, click on the 0.01 meters, and enter 0.1 meters. back to design along the bottom here. Then I go back to the structure tree, open and click the drop down for the beam profiles, and I'm ready to enter in my rectangular tube. So I'll highlight the rectangular tube, right click, edit beam profile, and this has an outside dimension of 0.12 meters and an inside dimension of 0.1. So I need to make sure that I follow the dimensions given here as they're shown over here on my graphic. So my W1 down here along the bottom is going to be 0.12, so I'll click on W1, click on the 0.1, and enter 0.12. My W2, I can see, is this vertical dimension here. That will also be 0.12, so 0.12, enter. Now I enter all my thicknesses, and my thicknesses are all going to be 0.02. So I can come to T1, click on the 0.01, and enter 0.02, enter. And I need to do that then on all of these thicknesses of my rectangular tube. And my last one here, left click on the 0.01, 0.02, hit enter. And now I have my rectangular cross section. I can use my middle roll button and roll in and see that my geometry is what I wanted. I'm ready to go back to design, structure tree, my drop down, and I actually need to add a hollow circle here. So I will come back up along the top axis to prepare, click the drop down and add a hollow tube, create, and come over to circular tube, highlight it, right click, left click, edit beam profile, and I will enter in an outside diameter of 0.12 and an inside diameter of 0.1. And you can simply click on that dimension again to highlight it and make sure that it is the dimension that you want to have shown. So coming back now down along this bottom axis, I can easily scroll through each one of these cross sections, and using my middle roll button I can roll in and roll out. I can check to make sure that all my dimensions are the dimensions that I want to have. So I'm ready to go ahead and add these. I can come along the bottom axis and close out these windows. I won't need them anymore. So I just hit the X and close them out, or I could certainly leave them up. Then I'll click on my design and come back to my structure, and here are all my profiles. I'm ready to go add these to all of these curves. Before I can add these cross sections though, I need to turn these lines into beams. And that is done by coming over and selecting each beam. So I select and then control select all the other beams, and you can see that they are grayed out. And when I go ahead up here and click create, they're all going to be created with the same cross section. So you can see here that my last cross section defined was my circular tube, and all of these beams here have been defined with that circular tube. That's easy to change. I can come up and click on my display and highlight solid beams so that I can now see my beams. And I want to come back to design and change my mode to 3D mode, and now I can see all of those. Let me check that again, 3D mode, and now I can look at those, and I can come back up here and click on the beam that I want to change. Now that I have my truss all sketched up, I'm ready to change these different cross sections. So to do that, I can come back to Design and hit my Return to 3D. Now I can come up and click on this top one. It highlights the member that it is, and I can scroll up here, and this member is actually my square solid, my first one. So I'll come to this drop down and I'll click on rectangle as my first defined member. I can now click on this member, and this was my, or I can just go down the tree list. I can click on the next one and rotate up. This one is my circular solid, so by the way I did this, my circular tube is okay, defined that way. Click on my next one. This member was actually my first circular solid, so I can rotate up, click the drop down, and click on circle 1. I can continue down the list, rotate up, and this was my circular tube, so again my default there for circular tube is okay. Actually, this member up here is my circular solid, so I do need to change that one. I can come up and click on it, roll up, click the drop down, and pick circle 2. And the last member that I need to set is this tube, square tube out here, so I can click on the member, roll up, click the drop down, and click on rectangular tube. And now all my members have been loaded as cross sections. I'm not going to worry about the different materials here. I will worry about the different materials for these members in mechanical. I've already added the material, so that'll be an easy thing to do in mechanical. The thing I do need to do though is come here and tell mechanical that all of these beams are connected. And to do that, I will left click on the top beam and then shift click the bottom beam, then right click and click move to new component. So I'm going to take all of these individual beams and build a new component. So click on move to new component. Now I need to come and click on that component, come down to the properties and scroll up, and I need to change the share topology from none to merge. I want these beams to be merged together at their connecting points. Now I am done with space claim. My model's been developed. I'm ready to go into ANSYS Mechanical and pull in the space claim. So I will minimize this window, double click on model. You can see I have a green arrow in my geometry. My model's ready to come up, so I'll double click model. Down here in the bottom it says starting mechanical. Again, this can take some time, but will eventually come up. So my model has come up. It's kind of in a skewed geometry. I can click on these different axes and align the geometry to what I like. I can come over and rotate this around so that I get close to what my model is like in my actual picture. And you can see that you can rotate it however you want to. One thing that might help in the rotation is to turn on the material cross sections. To turn on those cross sections, all I need to do is come here to the geometry and make sure that my components came in correctly, and I have all these green arrows showing that they do, that they did come in. I have one component made up of all of these individual members. I can also click the drop down or the tree on my cross sections and see that all of these cross sections have come in and transferred to mechanical with green checks as well. I'm ready to go ahead and do a mesh. I don't need to do any coordinate system changes, and I don't need any connections because I made one component. So I will right click on mesh and left click generate mesh, and there is the mesh. You can see the different cross sections, and that's a fine enough mesh. I'll just go with this default, and now we're ready to go ahead and define the rest of the model. You can see that I've got green checks down to static structural, so I'm ready to come to static structural, right click and insert some boundary conditions. I'll insert a fixed support, so I'll come up and click the vertex select, click on that point, click apply, and I now have a fixed support there. I'll right click again on static structural, insert displacement, and I'll select this point down here. Now I need to make sure I use my coordinate system as defined over here, and I actually want my X direction to be fixed. So I will come to my X component and enter in a 0, and I'll leave the Y and Z components free. I'm ready to enter my force, so I'll right click, insert force, I'll click the node, and I'll come over here and click on vector, select components. Now I can enter in X, Y, Z components. My horizontal force in this case was 200 in the positive X, so I will type in 200, enter. My vertical load, which is actually the Z direction, and since my load's going down, it's going to be positive Z, I'll enter in a positive 1000, enter. And I now have my force component, and if I click back on static structural, I can see, actually I have messed this up. I need to go back and change this. I entered my force at the wrong point. So what I will do is I will come to force, right click, select delete, and delete that object. Now I'll come back up to my displacement, and with the check mark there it says no selection, so I need to click my vertex select this point, click apply, and now I have a green arrow on a green check on my displacement. So again, I'll right click on static structural, insert force. I'm going to select this point as my geometry, click apply. Now my force is up in the correct position. So I now need to enter the force, so I will come up to static structural, right click, insert force. I'll come over and click this node and apply. I will change from defined by vector to defined by components, and I'll enter my components. In the X direction I will have a load of plus 200. Now this vertical direction in this model is defined by Z, and actually pulling down is in the positive Z direction. So down here on positive Z I will enter 1000, and my force has been generated. When I click back up here on static structural, I can see my fixed support, my displacement, and my force. Everything here has green checks, so it looks good. I'm ready to come and right click on solution and add some outputs. So right click, insert deformation total, and I will also right click, insert beam results, and I'll look at an axial force. Right click, insert beam results, and maybe a bending moment. And I'll also enter a beam tool, so right click, insert beam tool, and I'm ready to hit solve. So I will right click again and left click on solve. The model is now solving. I have green checks and everything, so my solution turned out to be to have solved. I can look at the different results. There's a direct stress, and that makes sense. All of them are constant colors. A maximum combined load, a total deformation. That appears to make sense, where this would point out here would have the largest deformation. These points back here would have very low deformations. Now this is all assuming that my material was made of structural steel, and I have various members in here that are made out of aluminum. So I can come back up here now to geometry, open the drop down tree and click on it, and then down here I can come and look at this rectangle, and I can see all the details of that particular beam, and I see that the material assignment is structural steel. This is one of the beams that I wanted to have aluminum, so I will click the drop down and click aluminum. I also wanted this member here to be aluminum, so I'll go ahead and click on that member, which is this rectangular tubing. It's highlighted in green, and I'll come down and click on the material assignment, click the drop down, and click aluminum alloy. Now I've changed my materials, and I can come down, and you can see now that my green checks from my solution have now turned to lightning bolts, implying that my model has changed and I need to resolve it. So I'll right click on solution and click solve. And again, it'll be sent out to solve. I have green check marks. My solution looks good. I can see that my values have changed slightly due to the change of materials. My axial force, my direct stress, my minimum combined and maximum combined stresses, and my model looks good. This concludes the tutorial on 2D trusses. Thanks for watching.